now that we got the boring one done, let's take a look. So, the technique we use of adding a bunch of rectangles is what we call a Riemann sum. It's the technique of partitioning an area into n number of rectangles and then adding them or summing them together. We use these all the time to approximate areas. For example, let's take a look here. A car is traveling so that its speed never decreases, kind of like how I drive. The velocity at the car at various times is on the table below. The first question says, use a left-hand Riemann sum to estimate how far the car traveled. Now the first thing is, well, how do I know that the area is going to give me distance? Well, I can look at this. If I were to think of this as a rectangle, I would be multiplying them. So if I were to think of this as like a distance time graph, here's my time, and here is my velocity. Well, velocity is being measured in feet per second. If I think of an area, my velocity is feet per second. So there's my length. My width is my time, which is measured in seconds. Notice those cancel, and I'm left with feet. So I know that an area is going to give me distance traveled. It's going to give me my feet that I want to find. So we want to do this. So for the first 10 seconds, we're just going to set this up. We want a left-hand sum, so I'm going to set my numbers here. It doesn't tell me how many rectangles, so I'm going to use them all. So I'll go from 0, 2, 4, 6, 8, 10. So between 0 and 2, I'm going to use a number on the left. So between 0 and 2, left is 30. So I'm going to make a rectangle that has a height of 30. Between 2 and 4, I'm going to write a rectangle. Between 2 and 4, I'm looking at 36. Not drawn to scale. Between 4 and 6, I'm looking at a rectangle that has a height of 40. Between 6 and 8, we're looking at a rectangle that has a height of 48. Between 8 and 10, we're looking at 54. So I want to find the area. Well, area in this case, it's just going to be, remember, my change in x, which in this case is 2. Each one of those is 2. Be careful, they're not always going to be 2. And my value of my function, c. So I'm just going to take this f of c delta x, and I'm going to write them all out. Well, f of c this time, for my first one we picked at 2 was 30. So I know this is going to be 30 times 2, my delta x, plus my next one had a height of had a height of 36. That's my height. Remember, this is just a rectangle. There's my height. There's my base. Base times height. Area of the base, which is 2, times the height, which we said was 30. So the next one is 36 times 2, plus 40 times 2, plus 48 times 2, plus 54 times 2. And there's our answer. And this is going to be, of course, in this case, sorry, not meters, but feet. There we go. That's going to be in feet for us. And if we add them all up together here, one thing I can do is I can just go, I'm going to use cheat 30 plus 36 plus 40 plus 48 plus 54, enter, and I multiply that by 2, and I get 416 feet. You don't have to simplify it, but it's kind of cool to do sometimes. Now let's do the same thing for a right Riemann sum. We're going to do the same thing. 0, 2, 4, 6, 8, 10. But now I'm going to pick the number on the right. So if I look between 0 and 2, 2 is on the right, and that's at 36. My first rectangle will have a height of 36. My next rectangle goes between 2 and 4. 4 has a height of 40, so there we go. 4 and 6, I'm using 48. 6 and 8, 8's on the right, so I'm going to use 54. And then between 8 and 10, that's 60. And I want to find my area. Again, each of my delta x's here is going to be 2, and we have a height of f of c. And I'm just going to do my area. F of x, f of c, times delta x. Remember, my height of my rectangle, f of c, there's my height, there's my width, there's my base, and I'm just going to add them all up. Ready? The first one, my first height is 36 times 2, 40 times 2, plus 48 times 2, plus 54 times 2, plus 60 times 2. Now, you need to have your rectangles get full credit. You need to have your formula for full credit. We'll talk about another way to write this starting tomorrow. and then you need your answer with your unit. We already know it's going to be feet for us. Very easy to do. So we can use Riemann sums to answer all sorts of questions. Obviously, we got it from a table. We can even use it from an equation. So let's take a look at number 3 right here. We want to use a midpoint Riemann sum of 3 subintervals to estimate the area under this following curve, e to the x plus 1. On the domain 0 to 6, make sure to show your rectangles. These are something I'm looking for. So this is telling me we want 3 rectangles, which isn't so bad. So let's go ahead and try it. We don't have to graph the function. We're just estimating. So here's what we're going to do. Between 0 and 6, 0, 1, 2, 3, 4, 5, 6. I want 3 rectangles. So I got to get delta x. Let's get our delta x. Delta x is going to be 6 minus 0 over 3, which is going to be 2. So each rectangle is going to have a base of 2, which means I have to kind of go out like so. I'm just making my rectangles. I don't care what the answer is right now. Now I need to know what type of Riemann sum. Well, they're telling me midpoint. Midpoint says in the middle between 0 and 2. Well, what's my midpoint? That's going to be 1, 3, and 5. This is going to give me my heights. So that's what I want to find, my heights here. At 1, what would be the height of my function? Well, at 1, it's just going to be e to the 1 plus 1. That becomes e squared. At 3, what's my height going to be? Remember, I'm using my midpoint. What's between 2 and 4? That's going to be e to the 4th. And then my last one, e becomes e to the 6th. So, ready? We know delta x, so my area, the area under this curve. Imagine, if this is my velocity curve, we're getting our displacement, how far we traveled. So this is just going to be for us f of c delta x, which we already know. My first f of c is e squared. Whoops, don't write delta x, times 2 plus e to the 4th times 2 plus e to the 6th times 2. And we're just going to leave it like that. I don't know what that is. It's not going to be very pretty. But that is an approximation for our area, which is an approximation, so we should put a squiggly there instead. Sorry, that's a weird looking squiggly. And there we go. So you try one real quick, pause it. 4 subintervals for sine of x from 0 to 2 pi. And I'll go and do it as well. So pause if you need to. So here we go. I'm going to do it right now. I'm going to go from 0 to 2 pi. I want 4 subintervals. That means I want 4 rectangles. Right there. So if I break it down, in the middle, that's 2 rectangles. Break it up again, pi over 2, 3 pi over 2. This is now going to generate how many rectangles? Again, I'm not looking for accuracy. I just want to get the rectangle itself. And now we've got to decide which one we want. They want a right-hand sum, so we can use the number on the right. So pi of 2, pi over 2. So now we got to get our heights. We already found delta x, right? Remember, delta x is just going to be this 2 pi minus 0 over 4, which is how we got that pi over 2. So each rectangle, so each one is just going to be pi over 2. We just got to get the heights by plugging in our right endpoint into this. So the first one's going to be sine of, sorry about that. The first one's going to be sine pi over 2, sine pi, sine 3 pi over 2, and then the sine of 2 pi. Now remember, the rectangles are just really there to help you, but I want to see them. So to get our area, we're going to take that f of c, delta x. Now remember, it's an approximation, so squiggly. So when we do this, there we go. I don't want to leave that sine of pi over 2. Sine of pi over 2 is 1. So I'm going to go 1 times pi over 2 plus the sine of pi is 0 times delta x pi over 2 plus the sine of 3 pi over 2, which is negative 1 times pi over 2 plus the sine of 2 pi is 0 times pi pi over 2. Oh, interesting. Look what here. That's 0, and these are the same. We're just going to get 0. We have an area of 0. Weird to think about this as an area of 0 if we think about distance, right? Distance traveled. But remember, this is a displacement. And if you think of the sine curve, what it looks like is this. Remember, this is positive, but this is going to be negative for us. They're going to cancel out. We're going to talk about that in a couple of days. All right, so let's go on here real quick. Let's take a look at a graph. Ready? We want to estimate the area underneath this function, bounded by f of x, on 1 to 6 using 5 equal intervals here, using a right Riemann sum. So I'm going to set this up. I kind of got it set up here. I'm just going to use my graph here. So we want to use a right Riemann sum. So between 1 and 2, I'm going to use the right. So take a look here. Going up here, I'm looking at this rectangle. Remember, this is going to be my f of c right there. So I already have the graph. I might as well just use it. To get our area, remember, we're going to use f of, sorry, I don't know what's on my iPad here. F of c delta x right there. Remember, my delta x is going to be pretty easy. 6 minus 1 over 5 is just going to be 1. That's nice that they turn out to be 1 all the time. So my first one, my second rectangle, using a right, I'm going to use 3. There's my rectangle. 4, there's my rectangle. 5, there's my rectangle. And 6, there's our rectangle. So we have all of our little rectangles right here. So finding the height at 2, it was 1, 2, 3. My delta x is 1. Plus the height at 3 was 1, 2, 3, 4 times 1. 4, 1, 2, 3 times 1. 2 times 1. And then, of course, 1 times 1. I just look at each rectangle there. And I can add them all up if I wanted to. 7, 10, 12, 11 units squared if you want them in terms of units. All right, so try number 6, but I want to move on to something else. Try number 6, you can get that one, but I want to take a look here, increasing or decreasing. This is kind of a big thing to do. We want to know if we're either over or going to be underestimating a Riemann sum. This is how we determine if we're going to overestimate or underestimate. So the first thing we do is take a look at a right-hand sum. If we have a function that is increasing and we're taking a right-hand sum. So if I go from A to B here, I picked the one on the right. That's going to be B. Take a look. Obviously, this is going to be an overestimate. So we say if the function is increasing and we're taking a right-hand sum, it's going to be an overestimate. So we would say this. If f is increasing and a right-hand sum, then it's going to be an overestimate. So if f is increasing and we have a right-hand sum, it's going to be an overestimate. Now, what if we did a left-hand sum? Well, this is my left side. There's my left. Right? Remember, that was my right. Now, it's going to be an underestimate. Clearly, we don't go over. So we say if f is still increasing, is increasing, and we use a left sum, then it's going to be an underestimate. So what if we have a decreasing function? Well, let's do the right-hand side again, from A to B. There is my right hand. There it is. There it is, right there. So we can say this. If f is decreasing and a right-hand sum, then it's going to be an underestimate. Likewise, what if we did a left-hand sum this time? Right? That was my right. Here's my left. now it's going to be an overestimate. So there's actually two things going on. We have to know if it's going to be increasing or if it's going to be decreasing. So if f is decreasing and a left-hand sum, then it's an overestimate. Don't overestimate my powers. Don't underestimate my powers. There we go. All right, hope you guys enjoyed the videos. I will see you all later. Bye-bye.